Dear viewers and subscribers, I hope you're all well. And today we are covering whole certification of Amazon AWS Cloud Practitioner course, right? In this video, we will be discussing all the lectures to complete this course, where outline is. Let me elaborate in shortly so that we will be later cover all these one by one in the same video today. First, we will be discussing Amazon AWS Certification Roadmap, where we will be discussing the sequence of certification when you start working with the AWS cloud platform. Uh, what is the first certification you have to start, which is Cloud Practitioner, because it provides basic knowledge of cloud, especially Amazon. And then you, after Cloud Practitioner, which one is next to start with? And then Amazon S3 use case discussion. First, you will create a use case. Okay, definitely once we have requirement, then we can understand the concept behind that, the technology or any other thing. Okay, so S3 use case. After that, we will be discussing S3 with practical example. To fulfill that use case, we will be doing practical example. Then, what is S3? Actually, it's a object storage, right? In detail, we will be discussing in the next slide. Okay, create EC2 instance. We will also be discussing how to create EC2 instance, and we will be discussing all types of EC2 instance, right, in the AWS. Networking and access rules in AWS. How we can perform, how we can do some kind of networking, how we can connect some component with each other, and how can implement rules and check either that rule is readable, accessible, or public, private. So all of this we will be covering here. Amazon VPN pairing, virtual private network, the connectivity of VPN pairing we will be discussing, and then we will be doing a practical example. After that, Amazon RDS relation data source with detail. So we will also be discussing in detail RDS, and same we will go with example. First we will be discussing concepts on RDS, and then we will create work with example. Then we have very important identity and access management, where you will be creating some row group and then users, and you will be assigning some rules, and then you can check either assigned rule is working or not. Then we have EFS Elastic File System provided by AWS. Its concept detail we will be discussing today. Then AWS, Amazon providing us auto healing and scaling in AWS. So we will also be discussing what is scalability and what is healing, is its concept. Then we have another number 14, highly available application in AWS. So how we can make our deployed application highly available. Then we have DynamoDB, NoSQL database, and in last we will be discussing AWS cost calculator, with which you can calculate your selected resources, and you can do comparison whatever you have on premises and whatever you have on cloud. Then you can go with your suitable approach. So let's start with this outline and all these sessions. Today we are going to start with AWS certification, and first of all I will be go with overall certification roadmap, where we will be starting with cloud practitioner, because cloud practitioner is available to uh, show us essentials and basic concepts what AWS platform provide us. And then once you complete Cloud Practitioner, you will be available for Solution Architect, Associate. You must be completing this certification to move forward, and then you have number of option like you can move on to sys operation, DevOps like administrator associate, developer associate, and from system operation administration to you can move on DevOps engineer professionals, and from DevOps engineer professional you can move on security, advanced networking. uh, this is one path. If you are interested you can go. And second is from solution architect associate to you can be a solution architect professional as well, and this is another part. So third is from a solution architect to developers, then you can move from developers to again DevOps engineer, and further as we discussed. From developers, you can also move to data engineer and then database specialty. Okay, so you can also fourth option is from solution architect to machine learning as well. So definitely, first we will be covering Cloud Practitioner, which is essential and basic concept about AWS, and this is a badge you will be. It will be available to you once you complete this certification. Then you can claim, and it will be available to you. You can post on your social media like LinkedIn, Facebook, and anywhere else. You because AWS providing you a link for this badge, and then you will be available for preparation of exam, and you can attempt actual exam to get this certification and be certified. So let's start with the main courses, main areas of Cloud Practitioner. What actually Cloud Practitioner offer is actually uh, like cloud computing essentials. Here we will be uploading our static web page, and it will be highly available for the users. And then we will be having cloud first steps, where it will be providing us reliability and availability of computational modules like EC2. Then we will be having computing solutions, cloud economics, network concepts, connecting with your private clouds itself, databases in practices, core security concepts, and a file system in the cloud, how it works, auto healing and scaling application. Let's suppose if you have some services deployed, and due to heavy load you need load balancer, you need automatically scale mean increase and decrease your services on the base of requirement. So highly available web application, how you can make highly available to providing to make available services, its replication in different uh, regions. Okay, and then first no SQL database we will also be covering. So let's start with our first cloud computing essentials, where we will be watching first video. In video we will be having some insights and basic concepts of this practice, and then we will start working with lab. So let's start watching videos.
AWS Global Infrastructure. The AWS Global Infrastructure delivers a cloud infrastructure companies can depend on, no matter their size, changing needs, or challenges. It is designed and built to deliver the most flexible, reliable, scalable, and secure cloud computing environment, with the highest quality global network performance available today. AWS provides the most extensive global footprint to ensure your worldwide customers are served. You can rapidly expand operations to virtually any region or country. AWS now spans 105 availability zones within 33 geographic regions around the world. The footprint is expanding continuously with announced plans for 18 more availability zones and 6 more AWS regions. This fast-paced expansion of region is also paired with Amazon's long-term commitment to a sustained future, using renewable energy sources. The AWS global infrastructure consists of the following main components. Amazon Cloud Computing resources are hosted in multiple worldwide locations, referred as AWS regions. Each AWS region is a separate geographic area and has multiple, isolated locations known as availability zones. A AWS region has at least 2 availability zones, most have 3, including all new regions, and several have as many as 6. They are fully isolated and are many kilometers apart from each other for complete redundancy. Each availability zone consists of 1 or more discrete data centers, typically 3, and at full scale can be hundreds of thousands of servers. To ensure maximum reliability, each data center has redundant power, dedicated metro fiber connectivity, and housed in separate facilities. Network. Every data center, AZ and AWS region is interconnected via a purpose-built, highly available, and low-latency private global network infrastructure. The network is built on a global, fully redundant parallel fiber network. Points of presence. With Amazon CloudFront, AWS operates the largest global content delivery network, CDN, of any cloud provider. It enables customers to securely deliver customers' data content to end users with lower latency and high transfer speeds through a worldwide network of global points of presence, POP, locations, which consists of edge locations and regional edge cache servers. Availability zones make partitioning applications as easy as it can be. If an application is partitioned across availability zones, companies are better protected from natural disasters, such as lightning strikes, tornadoes, earthquake, and more. In this example, you can deploy your application across 3 availability zones, and a load balancer is used to distribute traffic across them. If one availability zone experiences an outage, traffic is routed to other availability zone. Customer application is still up and running. Here are the benefits of the AWS Global Infrastructure. Performance. AWS Global Infrastructure ensures high quality and uninterrupted performance. It offers customers a high-performing, low-latency, highly scalable, high-availability, secure cloud infrastructure and responds to changing needs fast, without any drop in performance. AWS provides customers with the highest levels of availability and reliability. AWS availability zones are designed for physical redundancy and provide resilience, enabling uninterrupted performance with no single points of failure. Every component of the AWS infrastructure is designed and built for redundancy and reliability, from regions to networking links to load balancers to routers and firmware. In addition, the AWS global infrastructure is built on Amazon's own custom hardware, such as custom, purpose-built compute servers, load balancers, routers, and silicon. AWS optimizes this hardware for only one set of requirements: workloads run by AWS customers. By using custom hardware, AWS provides customers with the highest levels of reliability, the fastest pace of innovation, all at the lowest possible cost. Security. Our core infrastructure is designed to meet the more stringent security requirements in the world. It is built to satisfy the security requirements for military, global banks, and other high-sensitivity organizations. Our infrastructure is monitored 24/7 to help ensure the confidentiality, integrity, and availability of our customers' data. Scalability. The AWS global infrastructure enables companies to be extremely flexible and take advantage of the conceptually infinite scalability of the cloud. Customers can provision the amount of resources that they actually need, knowing they can instantly scale up or down, along with the needs of their business. Companies can quickly spin up resources as they need them, deploying hundreds or even thousands of servers in minutes. Low cost. With the industry's most extensive data center footprint, the AWS global infrastructure enables more customers to benefit from cloud economics of scale and reduce the total cost of ownership, TCO, of their overall IT infrastructure.
Okay, so we have gone through the AWS global infrastructures, its infrastructure components, highly available applications, and benefits. Actually, what the benefits of this course is because for all of this, you need to have a login credentials. You have to first create your builder account, and then once you have create builder account, you will be able to complete this certification to go through all these steps provided by AWS. Actually, once you done this certification, then again you will not be able to do it again and again. So Max Reserve presented this video actually to you, to you can repeatedly go through and understand and do some practice. So let's see what is next. It's a global infrastructure benefits.
AWS Global Infrastructure Benefits. Here are the benefits of the AWS Global Infrastructure. Performance. AWS Global Infrastructure ensures high quality and uninterrupted performance. It offers customers a high-performing, low-latency, highly scalable, high-availability, secure cloud infrastructure and responds to changing needs fast without any drop in performance. AWS provides customers with the highest levels of availability and reliability. AWS availability zones are designed for physical redundancy and provide resilience, enabling uninterrupted performance with no single points of failure. Every component of the AWS infrastructure is designed and built for redundancy and reliability, from regions to networking links to load balancers to routers and firmware. In addition, the AWS global infrastructure is built on Amazon's own custom hardware, such as custom purpose-built compute servers, load balancers, routers, and silicon. AWS optimizes this hardware for only one set of requirements: workloads run by AWS customers. By using custom hardware, AWS provides customers with the highest levels of reliability, the fastest pace of innovation, all at the lowest possible cost. Security. Our core infrastructure is designed to meet the most stringent security requirements in the world and is built to satisfy the security requirements for military, global banks, and other high-sensitivity organizations. Our infrastructure is monitored 24/7 to help ensure the confidentiality, integrity, and availability of our customers' data. Scalability. The AWS global infrastructure enables companies to be extremely flexible and take advantage of the conceptually infinite scalability of the cloud. Customers can provision the amount of resources that they actually need, knowing they can instantly scale up or down along with the needs of their business. Companies can quickly spin up resources as they need them, deploying hundreds or even thousands of servers in minutes. Low cost. With the industry's most extensive data center footprint, the AWS global infrastructure enables more customers to benefit from cloud economics of scale and reduce the total cost of ownership, TCO, of their overall IT infrastructure.
Okay, great. So we also gone through the infrastructure benefits of AWS Global. What are the benefits apart from different kind of from regarding security, low cost, and itself availability, reliability, and performance. From security, definitely AWS providing us different kind of security, basic token base and open authentication. They also provide us kind of encryption as well. And benefits of low cost is you can scale your application up and down as per your need, because let's say you have number of resources deployed and there is not huge throughputs or your traffics, then definitely your load balancer take care of it to reduce number of resources as per your configurations. So same goes for availability and reliability. For availability, you can deploy and configure your services regarding regions and different parameters, and it's a huge reliable services. So let's move to the next.
Hello, and welcome to AWS Well Architected Overview. AWS Well Architected helps cloud architects design infrastructure that is built around 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. The AWS Well Architected framework includes hands-on labs, access to the AWS Well Architected Partner Program, and the AWS Well Architected tool, which architects can use to evaluate workloads, identify high-risk issues, and record improvements. Let us take a closer look at the 6 pillars that define an AWS well-architected design. The operational excellence pillar focuses on running and monitoring systems, and continually improving processes and procedures. The security pillar focuses on protecting information and systems. The reliability pillar focuses on ensuring workloads perform their assigned functions and recovering quickly from any failure to meet demands. The performance efficiency pillar focuses on selecting suitable resource types and sizes, monitoring performance, and maintaining efficiency. The cost optimization pillar focuses on understanding spending trends, controlling fund allocation, and scaling to meet business needs without overspending. The sustainability pillar focuses on minimizing the environmental impact of running your cloud workloads, such as energy consumption and resource use. How does the AWS well-architected tool help create a well-architected infrastructure? The AWS well-architected tool extends the well-architected functionality, best practices, measurements, and learnings into your existing architecture processes, applications, and workflows. It creates custom lenses, where you can add best practices pillars and questions based on what's most important to your organization. Using the tool, you can share your workloads and custom lenses with up to 300 individual AWS identity and access management, or IAM, users or accounts, or across an entire organization. Reviewing your workload against sustainability best practices in the AWS well-architected tool can help you understand energy consumption and environmental impact. The AWS well-architected tool is available in the AWS GovCloud region of the US, so customers with specific regulatory and compliance requirements can conduct self-service public sector reviews. You can learn more about the AWS well-architected tool and custom lenses by visiting the AWS well-architected website.
Amazon S3 Overview. Amazon Simple Storage Service, Amazon S3, is an object storage service. An object consists of data and metadata. The metadata is a set of name-value pairs that describe the object. Buckets are containers for objects stored in S3. An object is uniquely identified within a bucket by a key. For example, the object named photo/puppy.jpg is stored in the John Smith bucket and it is addressable using this URL http://johnsmith.s3.region.amazonaws.com/photos/puppy.jpg. Amazon S3 offers industry-leading scalability, data, availability, security, and performance. Customers of all sizes and industries can use it to store and protect any amount of data for a range of used cases, such as websites, mobile applications, backup and restore archives, enterprise applications, IoT devices, and big data analytics. Amazon S3 offers industry-leading performance, scalability, availability, and durability. It can easily meet fluctuating demands by automatically scale your storage resources up and down without upfront investments or resource procurement cycles. Amazon S3 is designed for 11 nines of data durability because it automatically creates and stores copies of all S3 objects across multiple systems. This means your data is available when needed and protected against failures, errors, and threats. Amazon S3 also offers unmatched security, compliance, and audit capabilities. It secures your data from unauthorized access with encryption features, and access management tools. S3 is the only object storage service that allows you to block public access to all of your objects at the bucket or the account level with S3 Block Public Access. You should enable block public access for all accounts and buckets that you do not want publicly accessible. S3 maintains compliance programs such as PCI DSS, HIPAA High-Tech, FedRAMP, EU Data Protection Directive, and FISMA to help you meet regulatory requirements. AWS also supports numerous auditing capabilities to monitor access requests to your S3 resources. Amazon S3 is the most supported cloud storage service. You can choose to work with a partner from the AWS Partner Network, APN, which is the largest community of technology and consulting cloud services providers. The migration partners can help you to transfer data to Amazon S3. The storage partners offer S3 integrated solutions for primary storage, backup and restore, archive, and disaster recovery. You can also purchase an AWS integrated solution directly from the AWS Marketplace, which lists over 250 storage-specific offerings.
Okay, guys, actually, we are presenting very comprehensive and in detail these certification. Definitely, we will be covering practically labs step by step after this these videos. So please don't forget to like and subscribe so that you will be receiving rest of videos and tutorials, classes, or courses intimation. So we also left two videos more. So let's see what we can understand and we can learn about Amazon S3 more features.
Amazon S3, more features. Amazon S3 also provides a wide range of storage classes. S3 Standard, S3 Intelligent Tiering, S3 Standard Infrequent Access, or IA, S3 One Zone Infrequent Access, or S3 One Zone IA. In the three Amazon S3 Glacier storage classes, each S3 storage class supports a specific data access level. S3 Standard is for general-purpose storage of frequently accessed data. It delivers low latency and high throughput, and can access data in milliseconds. S3 Intelligent Tiering is for data with unknown or changing access patterns. It automatically moves your data between a frequent access and an infrequent access tier based on changing access patterns, without performance impact or operational overhead. S3 Standard IA and S3 One Zone IA are for long-lived but less frequently accessed data. Since S3 One Zone Infrequent Access only stores data in one availability zone, it fits best for data that can be recreated. S3 Glacier storage classes are for long-term archive and digital preservation. S3 Intelligent Tiering, S3 Standard IA and S3 One Zone IA also have the same low latency and high throughput performance as S3 Standard. S3 Glacier Instant Retrieval storage class delivers the lowest cost storage with milliseconds retrieval. It is designed for archive data that needs immediate access. For archive data that does not require immediate access, choose S3 Glacier Flexible Retrieval, with retrieval in minutes, or free bulk retrievals in 5 to 12 hours. To save even more on long-lived archive storage, choose S3 Glacier Deep Archive, the lowest cost storage, with data retrieval from 12 to 48 hours. With a wide range of storage classes offered by S3, you can choose which ones best fits your data profile and use cases. To classify, manage and report on your data, Amazon S3 also provides easy-to-use management tools for granular data control. You can use S3 storage class analysis to discover data that should move to a lower-cost storage class based on access patterns. Then you can use this information to configure an S3 lifecycle policy that makes the data transfer. S3 lifecycle policy defines when objects transition to another storage class and when objects expire. It helps to manage your objects so that they are stored cost-effectively throughout their life cycle. In addition, you can use S3 cross-region replication to replicate data into other AWS regions. You can also replicate data within the same AWS region. S3 Object Lock. objects are locked for the duration of the retention period that you define and are protected from deletion. You can enforce, write once, read many policies with S3 Object Lock. S3 Inventory Report lists your stored objects, their metadata and encryption status. You can also use S3 batch operations to change object properties and perform storage management tasks for billions of objects. With S3 batch operations and a single S3 API request, or a few clicks in the Amazon S3 Management Console, you can perform batch operations such as copy objects between buckets, replace object tag sets, modify access controls and restore archived objects from Amazon S3 Glacier. Since Amazon S3 works with AWS Lambda, you can log activities, define alerts and automate workflows without managing additional infrastructure. With Query and Play services, you can run big data analytics directly across your S3 objects and other data sets in AWS. This means you can run big data analytics directly on your data stored in Amazon S3 that allows you to query data without needing to copy and load it into a separate analytics platform or data warehouse. Amazon S3 is also compatible with AWS Analytics Services, Amazon Athena and Amazon Redshift Spectrum. You can use Amazon Athena to query S3 data with standard SQL expressions. Amazon Redshift Spectrum also runs SQL queries directly against data at rest in Amazon S3, and is more appropriate for complex queries in large data sets up to exabytes. You can also use S3 Select to retrieve subsets of object data instead of the entire object, which can be up to 5 terabytes in size. It is designed to increase query performance by up to 400% and reduce querying costs as much as 80%. Versioning is a means of keeping multiple variants of an object in the same bucket. Buckets can be in one of 3 states: unversioned, which is the default, versioning enabled, or versioning suspended. When versioning is suspended, it will suspend the creation of version ID for new objects but preserve all the existing object versions. Once you enable versioning, the combination of a bucket key and version ID uniquely identify each object. After the bucket is version enabled, it can never return to an unversioned state. You can, however, suspend versioning on that bucket. You can use versioning to preserve, retrieve and restore every version of every object stored in your Amazon S3 bucket. Versioning enabled buckets enable you to recover objects from accidental deletion or overwrite. If you delete an object it is not permanently deleted, Amazon S3 inserts a delete marker. If you overwrite an object, it results in a new object version in the bucket. You can restore the previous version as long as the object has not been deleted.
Okay, now we have only last video.
Amazon Simple Storage Service, Amazon S3, Access Management. By default, all Amazon S3 resources, such as buckets and objects, are private. Only the resource owner, an AWS account that created it, can access the resource. The resource owner can optionally grant access permissions to others by writing an access policy. Amazon S3 offers access policy options that can be broadly categorized as resource-based policies and user policies. Resource-based policies are access policies that you attach to your resources, such as buckets and objects. Bucket policies and access control lists, ACLs, are resource-based policies. You can also authenticate certain types of data access using query string authentication and grant temporary access to others with time-limited URLs. User policies are access policies that you attach to users. Access can be granted to users using AWS IAM policies. You may choose to use resource-based policies, user policies, or some combination of these to manage permissions to your Amazon S3 resources. Access control list is a legacy access control mechanism. As a general rule, AWS recommends using S3 bucket policies, or IAM policies for access control. When Amazon S3 receives a request, it must evaluate all the access policies to determine whether to authorize or deny the request. First, let's look at resource-based policies. Access control lists. Each bucket and object has an access control list, or ACL, associated with it. Access control lists use an Amazon S3 specific XML schema. It defines which AWS accounts or groups are granted access and the type of access they have. When you create a bucket or an object, Amazon S3 creates a default ACL that grants the resource owner full control over the resource. You can use access control lists to grant basic read and write permissions to other AWS accounts. Bucket policies, written in JSON, are attached to an S3 bucket. It provides access permissions to the S3 bucket and all objects in it. Here is an example of a S3 bucket policy. This S3 bucket policy allows the principal, the root account, and the IAM user Alice under that account to perform any S3 operation. The wildcard asterisk character after the S3 in the action statement indicates that all S3 operations are allowed. You can perform S3 operations only on specific resources, as shown in the resource statement. In this case, only the S3 bucket with the name myBucket and all objects in it are allowed. As you can see, you can use the slash and asterisk after the bucket name to indicate all objects in the bucket. User policies control who has access to your Amazon S3 resources and is also written in JSON. You can use AWS Identity and Access Management, AWS IAM, to create users, groups, and roles in your account, and attach access policies to grant them access to Amazon S3. Let's look at an IAM policy example. Unlike bucket policies, an IAM policy does not require a principal element because the principal is by default the entity that the IAM policy is attached to. The first part of the policy specifies bucket level permissions. It allows the list bucket action, so that applications can list all objects in the test bucket. The second part specifies object level permissions. It allows put object, get object, and delete object actions so that applications can write, read, and delete any objects in the test bucket.
Okay guys, we have completed almost all the videos, because these videos have such a great knowledge, because don't get bored. You have to understand what actually Amazon is explaining about these services they are providing. Actually we have to take care and understand what actually access management, user policies, resource based policies, because when you will be go for certification and attend exam, definitely these knowledge will help you, because you when you will review all these videos and understand and do some R&D and Google to get more understanding about all these concepts, definitely you will be able to attend certification and you can complete your certification very easy. So now we have gone through all these videos to cover all concepts beyond the this lab. So now we will be starting our lab and follow all steps to complete this first class. Okay, let's start replay lab and see what happened. Okay, what is the goal? Amazon Simple Storage Service can be used to store any type of data. Great. And retrieve any amount of data from anywhere. Any type of data mean we can store files, objects, and we can retrieve it from anywhere, mean because it's a cloud based solution, and if you have permissions and you can have login credentials, then you can access these as well. So let's see how it works. So right now we have created city residence and web portal. So these city residents, citizens will be using this web portals to view this object storage in S3. Okay, and this is a policy applied to this objects, who can see, who can access, who can modify, whatever. So let's see, migrate the existing website to static web page hosting on Amazon S3 to improve. It's mean we can host if we have some static contents to be available every time for so that anyone can review and understand what we are offering, like some any hosting websites, hosting contents, we can just host on AWS as well. It's a very good thing. So that let's move what actually practice we can start with. Okay, so second is in Amazon S3, any type of file and any metadata that describes the file is called object. Objects are stored in S3 containers called buckets. So actually S3 have some name and we call it buckets, and we can store any file, any objects. And the solution uses S3 bucket to host a static website. As we discussed in Amazon S3, the static website can sustain any conceivable level of traffic. Okay, you don't care about of how much load, how many users are accessing that your Amazon web S3 bucket at a very modest cost without the need to set up, monitor, scale, or manage any web servers. Okay, so by using S3, these are the features providing AWS, which are cost effective and easy to manage, and rest of the things. Let's see in the practice. Along with the HTML files that supports web page functionalities such as client-side scripts and style sheets are uploaded. It's saying that apart from any animation and any CSS styling, you also need to upload with the same bucket so that can be available when any scripts get executed. When an S3 bucket is configured for website hosting, the bucket is assigned a URL when requests are made to this URL. Definitely, whenever you will deploy your static web page or place your content on S3 bucket, it will create a web URL, and that URL will be available for anybody to have access and can uh, view on the web page. For others to access the S3 bucket or specific object in it, permission must be. It's mean if you want to go inside buckets and access that file, you need to modify the file. You must have credentials and access granted to you. Here is an example, like object is this one, and effect mean allow a bucket policy define who can access the bucket and what type of operation can be performed. Bucket policy is written in JSON format, which is very simple and standard format. JSON is human and computer readable format using to store and retrieve data. JSON is used by many applications and throughout AWS. Very simple and easy to understand. City residents visit the city web portal. This is the URL provided by S3 bucket for beach web information. Actually, residents are interested to view beach web on online instead of visiting the beach and check the waves, which invokes a get request from the portal to URL of the static web page. Initial root object is named index.html. So this index.html must have some CSS, any other GS or any other dependent files as well to make this working. Rename index.html in S3 bucket to wave.html, and then update the S3 bucket settings to use the rename root object. Okay. Plan. Rename index. Now our objective is to rename that index.html. Rest of practice will be done, and let's see how we can do this. Okay, so guys, let's start with practical. Now we'll be hosting a static web page on S3 and see how it works, right? And first of all, I will be presenting all steps provided by AWS, where you can see. Okay, steps are here as follows. We will be selecting S3, okay, and after it, actually these statics page already uploaded. Whenever will be creating as selecting S3, and we will need to create a bucket, and then after creating it will ask us to upload our content, our object. That can be a static website, file, object, whatever is. And then we can rename these files as well. It's a basic HTML and CSS and some JavaScript to execute scripts. You can also have number of files or folders as well, and you can rename any object from here, and then you can set permissions. From permission, you can edit bucket policy to make sure that effect allow action get object, and actually this is to allow anyone, right? And then it's a properties. You can review properties object as well, and you can edit static website hosting, where you can just hosting enable and host a static or redirected request to an object. Definitely we are going to host a static web page, and these are the our index by which we will be accessing actually this static web page. Okay. Then you can just upload and save changes, and copying URLs. This URL will be providing you, and you will be able to hit in the browser. And let me show you how we can create bucket and work with it. Let's see, I'm logged in with my account. Okay, and now I will be creating with general purpose bucket name is let's suppose test 001. It will check either it is already exist or not, and then ACL recommended disable. If you can enable it as well, uh, uh, then let's suppose all object in the bucket are owned by this account. Access to this bucket and its object is fetched using only policies. Object of this bucket can be owned by other AWS account. Access to this bucket and object can be specified using. So let's see we can specify or not. And then definitely all public access. Here you can see bucket object new, all these block public and cross account. Block public access, okay, we don't need to public access. Let's see, we disabled it, that the current setting might use an object within the becoming public. So I have to acknowledge that the current settings might result in this bucket and objects within becoming public. Okay, bucket version, we don't need to do this because just we are going to upload a static website, and rest of the settings are dependent on your use case wise. Okay? We are just going to do it with a simple. So bucket key, we don't need any key as well, and just we are going to create bucket. Okay, this is already exist. Okay, here is our bucket name. Let me create. Okay, great, we have created bucket successfully. Let me move into this. Now what we can do, we can upload our object. Either is it a folder or file, because we have a file, and Here we can upload test. Okay, and permissions, grant public access and access to other accounts. Okay, properties. Okay, standard, general purpose. Okay. These are the properties, and additional checksum. Anything else we don't need at the moment. Just upload. Now it will be providing us a URL by which we will be able to uh, access this content, right? And where we can find, here would be a URL, copy s3 URI. Yeah, here is our object URL. Let me see either it works or not. Access denied. Okay, so we need to specify access. Actually does not appear have style information. Okay, actually we need some configuration to see how it is worked, to make sure either this is a very correct configuration. Let me delete this bucket and see either same message exists or not. Instead of going through and modifying the account permission, let me delete bucket. Access grant, we can check, create access grant instance. Okay, we'll do this later in next video. And let me delete. We have to type its name. Type permanent delete. Now it is deleted permanently, and now see the buckets is available, and now we can delete it. We can just type bucket name and delete. Now we don't have buckets and its data anymore, and let's see to check either same message appear or not. Is it about access or not exist? Oh yes, no bucket and no specified objects exist. So this is very simple. We can upload an S3 bucket. We can move some contents from other service to S3 bucket for permanent storage as well. So this is very simple, and we will be now moving to different. What is EC2 instance, and how it can be created on cloud, right? And you know that we are just focusing on basic information of every topic within this batch. We will be covering in detail when we will start our next batch, like cloud architect. Okay, so uh, today what we are going to cover a use case, EC2 instance, and uh, the creating of EC2 instance with Amazon. Okay, and one more thing I wanted to explain you: every EC2 instance must be aligned with the subnet, and uh, we can have more than uh, one instance within one region but different zone, and every region must be under a virtual private cloud. Okay, and so let's start today's session. And here we will be discussing first our use case requirements, and we will learn what actually we are going to accomplish. The our requirements is creating an Amazon EC2 instance to run the computational module for the island stabilization system. Actually, what is the problem? Problem was when island stabilization system was deployed on premises on their own domain, it was creating some problems, sometimes getting hard disk crash, sometimes network issues, sometimes other power shortage. To overcome all these issues, we decided to uh, have our computational system on cloud, and for that we went for AWS uh, cloud platform. Okay, so let's discuss what actually EC2 is, right? We will be discussing every aspects. Uh, this solution improves the reliability and availability of the island stabilization system by moving its computational module to AWS global infrastructure, as we discussed, right? And the computational module can move to cloud by using the computer capacity of Amazon Elastic Compute Cloud. Okay, and AWS region is physical located around the world where data centers are clustered. Each region consists of two or more availability zones with a 99.99% service level agreement, as we already discussed. And uh, to improve availability, the computational module runs on EC2 instance deployed on separate availability zones. It's a good thing to note that we can deploy our replica in different zone within region. Okay, and all those replication must be with redundant, mean duplicated uh, configuration of what, like data centers, powers, networking, and connectivity. Okay, after that we must understand what actually Amazon EBS volume is. Amazon Elastic Block Storage is an efficient high performance block storage service designed for use with. So our concern is what actually it is. It is the same as we uh, deploy our application on uh, local machine or any deployment server, and definitely we have to provide some space on hard drive. This is same like hard drive available on cloud for this instance, EC2 instance. Uh, what the purpose of physical storage? It is the purpose to access some files, to store some files, images, runtime accessible for computationals and for any further processing. Though so it's a simple, like we have mm, physical drive folder space in our local machine. So let's go with the plan. What actually requirement is? The requirement is launch an second Amazon EC2 instance in different availability zone of the same AWS region. So once we learn how we can create EC2 instance within any zone in given region, then definitely we can create another EC2 instance with same configurations, same replica, just for selecting another zone. Okay, it's a quite simple. So let's uh, do some practice in uh, stepwise. So I will explain you all these steps because this is recording suitable and available for those who don't have access and who don't have created their own account. And also once you have created your own account, and definitely we cannot be do all these practice repeatedly, and this tutorial will help you whenever you want to recall, whenever you want to do more practice and remember that something you are missing or have to review and fix your knowledge. You can again come out on this YouTube channel and you can review all of these settings. And another good thing is you can ask me in comments what actually is missing, what actually we need to improve, what actually your requirements, so that it will be covered in next session. So right now we are going step by step how EC2 instance can be created with AWS Cloud. Okay, first of all, we must download, or we must have our own file containing all those instructions. Once we upload and run instance, AWS will be reading all those instructions and to create a instance. Okay, and it's will work like a infrastructure as code. Okay, once clicking, if you are doing first time your practice and created an account, then definitely we will be able to download this file. And please don't forget to save this file once you start this practice with your own account. Otherwise, you can ask me to provide you this file as well. Okay, after downloading this file, we will be writing here EC2 and click on EC2 instance. And also you can review in which region you are, right? After that, you will be navigating on dashboard. Uh, uh, you can see all instances already running, and because we are going to learn how we can create or launch new EC2 instance, so definitely we will be clicking on launch EC2 instance. After clicking this, we will name it, we will select operating system. You also can select any other operating system as well. And after that, we will be selecting Amazon machine image. Actually, this is a uh, free tier when you will create your builder account, and you will be able to do this practice with you. All those services available under free tier umbrella. So you will be discussing, sorry, you will be selecting this AMI, Amazon Machine Image, and then you can select instance type, right? By selecting instance type, it's depend on that what type you are going to select. Please take care when you will be selecting this type. You have to check it is available within free tier eligible. Otherwise, it will you will be charged, right? Then we don't need to create any key pair level configuration, because we will just need to create EC2 instance and we can just check either it is created and available or not. For security purposes, you can create your key pair and then you can use your key to access those instance. Now we can use already default network settings, and you can edit to just see how these configurations works. So let's see how actually we can configure. So again we will be selecting VPC, virtual private cloud network, and then its subnet. This subnet, as we already discussed, will be within a one zone. How we can check this? We can check this by using these availability zone. It's a A1, sorry 1A, and you can see it would be A B, A C, and etc. We don't need to assign any public IP, because it we just need to create an instance and see it. Okay, then you can create your own security group. what actually security group have. Let me explain you. You can name it, you can add some descriptions, and remember that you have to select type, which is HTTP, because we will be checking our created EC2 instance by using HTTP port, I mean from browsers. Okay, so once you select HTTP, then we will be navigating down, scroll down, and again you will be selecting some configuration like volume and processor, and then in advanced setting, in advanced detail, you will be able to upload already you have downloaded file, right? Once you upload this file, you can review that file to make sure that you have selected correct file and upload it. And you can also review all those content, either there is no any mistake, and it's a double check, right? After that, uh, you will be selecting number of instances. If you, let's say here you put five instance will be created with same configurations but within one zone, and that doesn't make sense right now, because just we are going to learn how to create instance, and how we can check it. Okay, so it's a final step to just launch instance. Once you click on launch instance, and if you are able to see success message, then you will be able to also uh, access your EC2 instance through browser. Once it is created, you can go to the view all instances, and then you can also write here EC2, and then see your running instances. Your new created EC2 instance will be available there. So after clicking view all instances, we will be navigating to all those instances we have created, up and running, and here is good to see that we have running our instances available. After clicking on this instances, you will copy this URL, public IP URL, and then after copying it, you will be placing in your browser, and it will look like this. So now our main goal is to create this instance and another instance, but within different zone. So it is availability zone 1A. First, let's start with this practice. Once we created this instance within this availability zone, this configuration, then we will try to create same instance with within another zone. Okay, so let's move to the our dashboard, and here we will be doing the same steps: EC2 instance, and I can also view my all instance already running. Okay, there is no any instance available. It's in progress. You can see no instance. Definitely I will go for to launch new instance. I will name it web server 01, and we will select our AMI, and it is by default selected, and you can see here is T3 micro. In previous in steps we have reviewed, there was T2. So for me it's available in free tier T3. So I will go with this, and don't forget to select this option. I really don't want any keep here. And after that, network setting. I will be editing this. I will be selecting my virtual cloud, private cloud. Okay, and then subnet. So guys, here you can see we have different zone available. 1A, 1C, 1B. Definitely first time I will select 1A to make sure that what steps I we have gone through to follow those steps exactly and see what happened. Then we will be selecting different zone for another instance, right? We have selected the subnet uh, with availability zone 1A, and yes, automatically assign public IP. Right now I'm not going to create name any security group and description, so I'm going with same as it is. And here is major thing which we have to consider: HTTP. If we are going to review and validate our instance with SSH, definitely we don't need to change it. But right now it will be simple. Instead of connecting instance and on CLI we have to create SSH session, then checking this all of this, it's a simple to just go with HTTP. And source type anywhere, from anywhere I can access this my instance. And uh, there is no anything, any change. I can also change general purpose SSD, different hard disk. And I don't need to add any volume. Let's review advanced detail. We don't need to do anything with this. And here is, we will upload file. Okay, uh, let's see. Here is a file user data I have already downloaded. And uh, now we can review it, so that it is correct file uploaded, and all those configuration we have, right? And okay, so we will be launching this instance and see what happened. Wow, you have created your instance, but now we need to check either it is available and accessible. To review the availability, definitely we will review all instances. Okay, great. You can check the status, it is getting initialized. Then once it is running and available, then we will be uh, able to review and access. You can refresh the status. It's taking time in initializing. I hope all will be okay. Okay, it's running. And see, after selecting, we will be having its public URL. Okay, now I'm going to check this instance. Continue. Okay, great. So guys, you can see we have created T3 micro instance. And this is instance ID. And availability zone is 1A. And now we will be creating same instance but with different zone. How we can do this? Let's review and start. Okay, I will create another launch instance. I will be writing web server 02. I will not change anything else, and just I will go to uh, selection of, I will be uploading file, and now I will be selecting launch. No. Uh, because our requirement is to change the zone. So here we need to also select keep here selection, and where is those selection? It must be under network configuration. Yeah. Definitely, we will not be changing virtual private cloud. In this case, you will be actually switching your infrastructure in different cloud. I mean, we will be covering this virtual private cloud in coming session, but please don't change, do any change with this selection. And now only here we need to take care. We already selected 1A, and now you can select 1C, 1B, whatever. And if I go to select 1C and rest of size settings, yes, HTTP, I want to check this, access this instance with HTTP port through browsers, and I believe we don't need to do any further changes. So let's try creating instance. It must be created in availability zone 1C because as we have selected. So go through all those instances available. Here you can see you have A1 which we already have created, and it must be available with 1C. Okay, great. It's getting initializing, and it is initialized, and you can see it is running. We can check this as well. If I copy this public URL and see, it must be available with different zone because we don't have any other configuration changes instead of. Oh, great. Now we can see this another instance is running but in different zone. We already created instance with zone 1A. You can see same instance type and uh, 1C and different zone, but instance type is same. So guys, this was very basic understanding of EC2 instance, its creation, and kind of some configurations. We covered VPC, selection of key pair, any other configuration related network like HTTP port, subnet selection. So in coming videos, we will be creating these instances with different configuration instead of this already having file with instructions. So let's meet in another video, session 4. Right now we have covered session 3, and please don't forget to subscribe and like, and please also do comments whatever you feel, we can improve and what we need in coming sessions, so that I can fulfill your requirements, because our goal is to complete these certification, prepare these exam, and also get certified badge. And today we will learn how and why we need to change the type of EC2 instance, right? Actually, there are different type of EC2 instance we can choose on the base of requirements. There are a number of, let's suppose if we have a use case to that our application is not performing well, uh, uh, or might be possible our application needs some more storage, our application needs some kind of different resources. So that's why on different types EC2 instance provide those functionality, and we when we need uh, some type of requirement, then we choose that type of EC2 instance accordingly, right? And here is a diagram of EC2 instance type and with its detail. For general purpose, we actually use D2 or M5. For compute optimization, we change EC2 instance of type C5. For memory optimization, we can choose R4 or X1E. For accelerated computing, P3, and etc. You can uh, review this and change EC2 instance type accordingly. So let's move on some use case discussion, and then we do some practice. Thank you. Here you can see uh, last time we created EC2 instance and access EC2 instance with the HTTP port, right? And definitely you must want to know that how we can access our EC2 instance with any other uh, medium. So we can access EC2 instance with the AWS System Manager, browsers, which we have covered in previous session. We can connect to, with SSH, as we have discussed as well, with terminal, and EC2 instance also we can connect it with EC2 instance connect provided by AWS as well. So apart from different these features to connecting with EC2 instance, let's move forward and choose any one of type to connect with EC2 instance. We have covered with port 8080, and today we will be going with any other options. And I would request you guys to try with rest of options, and please do some comments if you need some information, if you get any problem or anything you want to know, or anything you cannot find relevant material, you can ask me, I can provide you, and I can explain you in next video. Otherwise I can also help you in comments, or I can also provide you some material relevant to that particular problem. Now move on and do some practice, right? So let's see what is our requirement. Change the Amazon EC2 instance type to large general purpose instance. Okay, so we will be looking into this. First, definitely we will create EC2 instance. If we don't have created, if we already have EC2 instance, then definitely we can easily change its type, right? So first let me show you all those steps one by one very quickly. First of all, we will be selecting EC2 instance, and here we can see, okay, it's already running one EC2 instance. Then we can review its ID, its public IP, and its type. Here is its type of EC2 instance. Also, it is also provided here. Okay, so you can also review all these EC2 instance types by selecting instance types in the sidebar, and you can go through and select as per your requirement. I mean, you can review all these one by one and see what actually your requirements and which type suits your use case. So after that, we can also check running of EC2 instance as we did this in our last example. Just copy this public URL and uh, paste in browser to check either it's working or not, right? Which is accessing of EC2 instance with HTTP port. Here, if you remember, we did it. And now we can connect as we discussed that apart from HTTP with SSL, SSH, and there are also other way we can connect with EC2 instance. Let me show you. You can connect direct EC2 instance connect, session manager, SSH client, and its console, right? So we will be using any one of to just show you, and I would request you, you can try with others options, and you have to know when we need which option to connect with EC2 instance. In this example, we will be covering how we can connect with our instance with session manager, and here is just after connecting, clicking on connect, you will be navigated to CMD console, and from here you can navigate to different areas of your area of EC2 instance. Okay, like it is logged in with sudo super permissions, and then it navigated to app deployed on EC2 instance, and then listed all available files or folders, and then it's trying to print the log to check that either uh, instance is working or not. Okay, so we can also use another option uh, by going to actions and instance settings and edit user data. Here you can see current user data available connected to this instance. You can also copy these commands as well. Now, it's very important, you have to stop when you need to change your instance type, right? Once you click on stop, and it is another important thing you have to know that anything, if you it is already provided elastic IP and any other storage connected to that instance, you will be charged. If you are going to stop this instance for a long time, and you think that we might not be required this instance in future, then you have to consider, okay, what are the rest of things I have to remove, or I have to deregister, right? And you will not be charged when you stop your instance, only the data transfer. I mean, if definitely if your instance is stopped, no one can connect, and no one can access your any application if deployed on EC2 instance. Okay, once you have stopped your EC2 instance, you can see there is no any IP address assigned to it. Okay, and now we will be selecting action in instance settings, and then you can change instance type, right? After selecting instance type, then you will start instance again to review that your instance type must be changed, and you can see now it's uh, t3 dot small, and before that it was t2 dot small. So let's move on practical example, and let me show you. I have already logged in with my free tier user, and now I will be moving to my instances. Here I have two instances, one is terminated and one is stop, and to just save time, I have already stopped this instance so that I can show you how we can change our instance type. Right now you can see it's a t3.micro, right? And uh, I will also explain and show you rest of features in coming sessions. Definitely we will be moving gradually and in depth, and we will covering each and everything on AWS exams required for preparation any certificate, right? Okay, now I will be going to change my instance type before starting, and you can see it's a t3.micro, and I'm going to change it. Here is instance settings, and then I can change instance type. Here is lot of options given to me, right? For that, in previous step-by-step slides, we have seen that we can also check here from your current instance and your selected EC2 instance. You can also match the price, CPU, memory, each and everything. Here you can see I'm eligible for free tier, and it's not available for free tier. So uh, I will not select any, even though let me try with Nano. Yes, it's not costly than T3 micro, but it is not available for free tier. So let me change it for you, no problem. Type has changed successfully, and you can see here it is also changed t3.nano, right? And here I can also see t3.nano. Okay, so we have covered our actual requirement and session, and in next session, because definitely you will be wonder, okay, if there is any change with current setting, there might be uh, chargeable, might be some different categories have different charges. So definitely then let's connect in next section, and we will be cover calculation of our bill, our charges, whatever services are we going to select. Then we have to know how we can uh, review our prices of the selection services on the AWS cloud platform. Thanks for watching, and again I would request you to please subscribe my channel if you have not subscribed, and please keep watching, and don't forget to comments in comment box so that I can understand what I have to improve, what we can fix in coming sessions, right? And uh, let's connect in next section. And in this session, what I have missed, it's only connection of EC2 instance with different types like console, EC2 instance manager with HTTP port and SSH. So please try with all of these options and let me know if you are successful or not. Okay, in more detail you can go back and you can watch all video I have explained, and you can also ask me if you need more detail or anything else related to that particular video. So today what we are going to discuss, I have an example for you to understand easily. Let's suppose we deployed our web servers, right? And then we also have databases. Definitely we don't need to allow this database to be accessed publicly, because no one want to access this database directly, and there is no need as well. And definitely publicly only web servers should be accessible, and this database is only for that web server to be utilized to make any query, insertion, updation, whatever uh, we need to do with our web portal website deployed on this web server, which is in public subnet and accessible publicly. to avoid any uh, malfare restrictions and any other unwanted attacks, we actually need to uh, secure this database from outside of this virtual private cloud network. As you know that every account by default have virtual private cloud which is virtually available, and we can use further this private cloud for further deploying and accessing, configuring our required services. So how we can set private and public access? Uh, in this session, we will be just discussing use case, and we will see step by step. Maybe I will break this session into two more session, or at least one more session. This one is for discussion and other will be practically. So let me move forward and start on it, right? Today we are on sixth day where we will be discussing our network concept, how we can set public and private access. Let me show you. Okay, here is. Let me start lab for you where you will be able to review and understand and learn. So, review and change virtual private cloud network configuration to fix a connection issue. What is connection issue? Connection issue, this solution uses a common network architecture configuration that allows only internet traffic to reach publicly exposed AWS resources. So what resource we will publicly exposed, only it will be accessible publicly. This one is router, and this is internet gateway, and this is internet. From here, users will be accessing our web server, and web server internally communicating with the database, which is in private subnet and not available for public access. Okay, so let's move forward, and the requirement is change the security group rules to allow traffic over port 3306 into the DB server. This is the actually requirement, and definitely practically we will do, and we will do how it works and how we can set these rules. So let's move to practice. As you will have a virtual private cloud network, and then definitely mostly we use EC2 instance, a computational module, most of the to present more for most of the examples. Let's start with it, and click on EC2, and then you can review running instances if you have already created. In this example tutorial, it is already available web server and DB server. This web server we need to allow access publicly, but we don't need to allow this DB server to be accessible publicly. This will be available for web server. How it can work? Let's start. First of all, we need to check either web server is available publicly or not. We will be copying this public URL, and we can check this in browser. Okay, this is not available, so we have to review its networking, routing, security configuration to make it available publicly first. So after selecting web server, we can go into networking, and we can review these public IPs and private IP, okay, subnet IP, and then we can click on subnet ID. It will be navigated to different uh, dialog where we can go into route table to view how routing is configured. Either this web server routing is available to be accessed with HTTP port or not. Okay, after clicking this, we will be navigating to another screen where we can do select routes and then edit routes. Okay, so this show that it is available publicly, and let me check. Okay, actually it's a network access gateway. uh, uh, Definitely we have to use proper way to how can we connect with this, but definitely we are using browser and there must be HTTP port. 8080 mostly we used, and we must select an internet gateway. So definitely it will adding a route, and uh, again it is setting 000, mean from anywhere you can access, but it will be used internet gateway. Okay, and save changes. These are network routing settings. So we have provided internet gateway, and from anywhere we can connect. So definitely after that we will review, and route configuration has been successfully applied, and then we will be improving and configuring security groups. And let me click on security group and see. Okay, edit inbound rules. Inbound and outbound rules actually are how from public to your VPC, and it's a inbound. From VPC to publicly accessible, it's a outbound. So let's see. Okay, there is no rule to for inbound, because even though we have configured internet gateway, but again internet gateway is not able to communicate with our resources, because there is no any rule for inbound configuration. So we'll be adding add rule. Great. Here you can see we can set HTTP, and once we select HTTP, it will be uh, uh, automatically selecting 00 mean anywhere. Okay, you can choose, because you are going to allow your web servers publicly available for anybody. If you are going to select any IP, then definitely only that IP would be accessible. Okay, now you can click on save. It's mean from browser with HTTP port, from anywhere in the world you can access this web server. So you can also review this. It is also saying the same thing which I have explained. So click on save rules, and now inbound security group successfully modified, and definitely you have seen it is all server is running, and now you will be clicking on public URL, and now it you can see it is accessible, right? But still this server is not able to connect with database. Same configuration we need to do with our database server, as we were not able to access this web server even publicly or from private access, and we have configured internet uh, configuration, some routing and security configuration, and now it is accessible. But it is saying that I'm not able to communicate with database, and it's a issue with it. So uh, we have done public access, how to make any resource on cloud platform publicly available, we have done. And now as you have seen that we have uh, same this requirements. Okay, and to change the security group rule, as you have done with web server, we need to change security group rules, and HTTP port port allow only this 3306 with DB server, and we will be setting IP of this web server to make sure that only this web server can make connection with DB server. So in next video we will be doing some practice. Please be connected and subscribe this video so that you can get notification for practical session, and please don't forget to like and subscribe if you have not, and also press the bell icon. Hello guys, thanks for watching Maxi Service YouTube channel. Right now we are presenting AWS series of Cloud Practitioner, and I hope everything is going as per your expectation, and thanks for valuable comments. So I am going to note and will improve in coming videos for you, and please don't forget to subscribe if you have not, and also like and share in your circle so that rest of guys can learn the basics of AWS cloud platform services and features. So we have covered a lot of and we have discussed in previous sessions, and today we will be continue our last session, network concepts, where we have to learn how we can set public and private access to our instance. So definitely we have learned how to create instance, how we can change instance type, and apart from that you can review, we have done how we can change security group settings and networks settings. But today it is specific session especially to focus on how we can uh, make instance private to not be accessible publicly, and we can set for that private instance to be accessible for particular IP or any other service. So it's our day 7, and we will continue. Here you can see we have two server, one is web and one DB, and DB server will be accessible by web server, and web server will be accessible by publicly in through internet gateway. So let's start practical example, and because we have discussed uh, about use case and requirements, so today we will be covering practical example, right? First of all, I will go and create uh, instance, right? Let me, oh, sorry, let me find instance. Let me create. Okay, so we must have two instance. One is web server, which we need to be make available publicly. I am with free tier account logged in, and definitely I will not choose any other type which can be billable. So no keep here I want. So we can select another already created security groups, and we can also use, because uh, we have lot of uh, we have done a lot of practice sessions and we already have some security groups. So I'm going to select public access, and then in detail, just to make sure that my instance is up and running, I will upload data, and let me launch this instance. Okay, here is running this one, and I must terminate rest of. So terminated, and uh, instance will be deleted automatically later on. So just I'm going to terminate which I have stopped. Okay, so the instance we have created, it's initializing and running. In the meanwhile, let me create another session, sorry, EC2 instance. Okay, and that would be DB server. Okay, same configurations and no key pair. Okay, in last instance creation, I believe I forget to select uh, subnet. Yes, so I have to review that one as well. Okay, so addition of this demand selection of subnet, and also I'm going to let me create new security group DB security to just make sure that there must not be any confusion. Okay, and definitely I want this because it's a database service, so I want Aurora to be available. But definitely this is the main point. When I will make it to private, I will provide here IP of web server, and then this DB server will be accessible to that web server. Okay, so right now for just for checking and testing, I am going to change HTTP and anywhere, and again I will be uploading file and launch instance. Subtype is to t2.micro. Okay, now we have to look into EC2 instances, and we can filter it only running web server. Let me check this either I am able to access or not, because I created this instance web server with public access. Okay, and now I will be checking this either it is available publicly or not. Let's see. And at the same time we also copy this and check this. Okay, great. So instance DB instance is available publicly, and if you remember, uh, I doubt that I have not selected its subnet. So let me check this web server running, and yes, subnet is available. I have to review its configuration, either anything we need to change. Okay, it's available publicly as well, and what else I can check. I will have to check route, and in route we will check everything must be okay. Okay, so from anywhere it is accessible through internet gateway. Okay, and what else we can check? We can check security groups, and for security groups I have to go in security and yes, let me add it. Okay, so here you can see its configuration or not as expected. Okay, from anywhere. Now public access, it should be available. Great. Okay, now you have seen that I created security group with public access, but there were some issues with port and I assigned IP address different. So right now, what our assignment is, actually we have to check, okay, we have two instances, one is web and another is DB. I will check what is the IP of my web server so that I can provide this IP to DB server accessible, right? It's mean when I will provide in configuration of DB server the IP of web server, only web server can connect with DB server, and those configuration are inbound and outbound. Okay, uh, inbound mean from outside, I mean anything connected with DB server, it's inbound. Anything from DB server to outside of DB server, it is outbound. So we are going to restrict inbound. Mean we are going to restrict from HTTP to Aurora because it's a DB server first, and we want to accessible this DB server only by this web server. Okay, now we'll check. This is our web server. It is working fine. It should not be accessible now because we have changed port and IP address. So now if you want to communicate with DB server, we have to configure, and whatever we are going to deploy on web server, from web server we can configure our application to access this DB server with port 3306 and uh, uh, IP address only uh, given from web server will be accessible. So anything else cannot access DB server because we have provided IP of web server. So I believe you enjoyed and it's very informative, and please I would request to be connected and subscribe this channel if you have not, because in next session we will be discussing three things, sorry, two things. One, all concepts covered in this session: security groups, how security groups are works, how networking settings and configuration works, and we will be doing some FAQs, MCQs, sorry. We will be doing some MCQs for you so that you can go through and understand, because actually we are going to prepare our exam. Okay, so today we will be working on what is virtual private cloud peering, on its concepts and use case. We will go one by one about to knowing about how we can make VPC peering and its limitations, its use case, its life cycle, and rest of concepts. Okay, and after that, in next session with same topic, we will be doing some practical example. Please stay in touch and don't forget to like and subscribe if you have not, and please also press the bell icon so that you will be receiving all the coming sessions, so that you can also go through and complete your badge as well. And let's start with its concepts and add As we have seen that any VPC, virtual private cloud, dedicated to your AWS account. Remember that one VPC is only related to one account. One VPC cannot be belong to any number of account, mean more than one account. But one account may have one or more virtual private cloud network, right? Peering connection, connecting peering connection is a networking connection between two VPCs, your own or maybe it's someone others, to enable you to route traffic. What does it mean? It's sharing of files, access resources uh, between them using private IP version 4 and IP version 6. Uh, One thing was about VPC belongs to account. Second thing, it's can be your own VPC, one or more, and your VPC can be can communicate with others accounts VPC. Okay, so VPC can be within same region. These can be in different region. So if you want to connect and pair them, then you have to know all of these concepts we are discussing. But another important things, you must configure private IP version 4 or IP version 6 because AWS infrastructure only facilitate in this way. Otherwise, you will not be able to connect more than one VPC with each other. Okay. Another thing, VPCs can be in same or different regions. Okay, if there is region USA and there must be at least one VPC and it can be more than one. And let's suppose another VPC is App South, it is EU. Europe West, then you can see you can pair, you can connect these VPC with each other. All data transfer over VPC peering connection that stays within the availability zone, even if it's different accounts, is free. Okay, great. It's another thing we gone that uh, within same region, if we have number of VPC, virtual private clouds, then connection between them and communication between them, it's free. Charges apply for data transfer over a VPC peering connection that cross availability uh, zones and regions. Let's suppose above examples will be charged because one VPC is in Europe West and second is AP South. So you have to know and you have to take care where you are going to pair some VPC. Okay. Another thing which is remember is that VPC peering connection is not transitive. What is transitive mean? If you have VPC A and you have VPC C, then VPC A cannot communicate VPC C. Yes, if you created connection and you have configure peering, then definitely it can communicate. Otherwise, let's suppose you have paired VPC A with VPC B and VPC C with VPC B. Don't think like that because C and A are connected with B and can communicate with B. So that's why VPC A can communicate with VPC C. It's not possible. You have to make another pair between them. Okay. Okay, so to establish VPC parent connection, you do the following. Okay, number one, owner of the requester VPC sends a request to the owner of the acceptor. uh, these two VPC can belongs to one account and these can be in different accounts. So any requester VPC will send to another VPC as a request and destination VPC will be acceptor. The owner of the acceptor can be owned by you or another AWS account. As we discussed, VPC accepts reject the VPC peering connection request. Okay, uh, your acceptor can also reject your request. Okay, This is another good point. We have to know that overlapping CICR. What is CICR? It is actually classless interdomain routing. Classless interdomain routing. What its rule says, an example of overlapping CICR is the two VPCs are paired with the same CICRs. This situation is called overlapping CICR, which causes failure. It has to be mentioned that VPCs with IP6 must not have overlap. What does it mean? It's mean because every VPC, virtual private cloud, have range of IPs, right? If you have a VPC with range of IPs and another VPC, definitely that would be another range of IPs. So be careful while uh, adding your IP of source or destination must be different in range, right? You can see that here is in the same range 192.168, 192.198, because it must be, if it is 192 this it must be start from 193 or something else, right? Okay, this connection is not valid and you cannot pair. Okay, so another point, to enable the flow of traffic between the VPCs, owner must manually add a route to one or more of their VPCs route tables that points to the IP address range of the other VPC. Got it? Okay, let me explain. It says that there is no any user interface by which you can just uh, press a button, okay, connect, and just provide the name of other VPC and it will be automatically configured and start communicating. No, you must have to go through the subnet configuration and route table, where in route table you have to add another route and have to tell your VPC which is the destination to which you will be communicating. Okay, so for VPC A is this destination, for VPC B is this destination. Okay, let me explain a little bit more. Let's suppose VPC is A's ranges start from 172 and its IP is 10.10.10, and VPC B, okay, a VPC A's IP is 10.10.0, but VPC B is IP is 172, and you can see that as a destination VPC A provide 172 and VPC B provide 10.0.0. Got it? Okay. If required, update the security group rules that are associated with your EC2 instance. Definitely, we might have another service other than EC2. Okay, there might be another containerized service or lambda expression. We are just putting example EC2 with is common and uh, mostly used. So it's saying that there must be any group policy where you have to uh, configure and update your rules, like on which port you need to communicate and what is your inbound and outbound uh, 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 destinations, right? If you want to communicate, if want to allow VPC A only VPC B to be communication make, so you have to provide destination in your group policy. Okay. Okay, the next is, this is very important thing you have to take care while pairing your VPC. They saying that whenever you start pairing, there must be default public IPs, IP version 6 or IP version 4 mentioned. But be careful before pairing. You have to take care and resolve your host name and other things to make it private so that your VPC can communicate and start sharing. So here is another important life cycle of VPC. First is initialization of request. As a requester, initialize your request, and it can be failed due to some configuration like internet connectivity, any IP addressing mismatch, policy rules, any other things. It will go for pending acceptance, which can be expired if expiration of your VPC must be by default might be 1 week, or we have to go through the documentation. Okay, it can be rejected by acceptor if acceptor don't want to connect and don't want any peering. It can be rejected. uh, Otherwise it can be deleted. Okay, uh, other is provisioning and active. If your acceptor accept your uh, request, then it will be available with status of active. Okay, so this was basics concepts we have to know, and then other thing is use case. We have to go through the use case definitely to remember the things. There must be a real world example so that we can go through and do practically. Again, please don't forget to like and share in your circle if you already have subscribed. So let me start use case, uh, and also I will sharing all those steps in this session, and in next session we will be doing same steps in coming session. Okay, so let me choose today's session. We have covered all these and we are going one by one. Last time we discussed network concept to make private and public subnet, and today we will be working on connecting VPCs. Okay, great. Here you can see it's a virtual private cloud, and its name is marketing server, and with CIDR IP range 10.10.this, and uh, another is developer virtual private cloud. Its name is developer server, and third is financial service. Okay, so use case is that developer and marketing server needs to communicate with the financial service so that they can be connected and they can share their resources, like transfer data, sharing files, any other things. Okay, allow communication between applications hosted in different VPCs by the using VPC peering. The marketing and developer EC2 instance needs to access the financial service server in the finance department virtual private cloud. Okay, this is actually the use case, and this solution use a separate virtual private cloud for each department. Marketing, it's saying that it every uh, virtual private cloud will be different for every department like marketing, developer, and financial service. The VPCs are connected by using VPC peering so that the resource in each can communicate with each other. Okay, so let's move one by one and see all those steps. How can we do that? But remember that we will be watching all those steps pairing of marketing server with financial servers, and you will be doing yourself by pairing of developer server with financial server. Okay, so let's start. First of all, we will be searching VPC, and you will be creating all three VPCs. First of all, right now we have created like developer, marketing, and finance. What steps we need to follow to make communication between them? Right now we will be making pairing of marketing VPC with financial VPC, right? So there must be EC2 instance belongs to one VPC. Right now we can go through and see. Okay, here are three instances, EC2 instance for each VPC, right? And you can see as we have discussed in concept, there must not be any public IP address available. There should be only private. When you don't have any public IP available, definitely your VPC cannot communicate outside of the world, outside of your cloud. I mean, any other resource from internet cannot communicate with it. These VPCs can communicate with each other with private IP version 4 or IP version 6. So let's start and create a virtual private cloud. Before that, we can test either it is already connected or not. To do that, just go to any, let's suppose I am going to pair financial server with the marketing server and want to check either from financial server can I ping to marketing server or not, or from marketing server can I ping to financial server or not, right? So first I will note IP of uh, finance server, which is 1.83, and then I will go into finance server and from marketing, because we are going to check communication from marketing to finance server, and this is our we are going to follow these steps. So I will be going to throw marketing server and connect with session manager. We can connect with other source as well, but this is feature provided by AWS, and I'm going to connect with it. After connecting, I will ping my finance server. So after pinging, I'm not receiving any response, so it's mean these are not connected. We have to pair. Okay, so let's start one by one, and you can see that other settings. You can also go through your any VPC and its routing. So let's start peering. You will search peering connection from navigation bar. Just select peering connection and create peering connection. You must name your pairing connection, because I am going to pair marketing with finance, so that it can be, I can remember this name. Okay, and here you can see requester is marketing. Okay, and its IP is 10.10.0. Okay, CIDR, and you can see acceptor is finance, because I'm going to make peer marketing with finance, and its CIDR is different, it's not overlapping, so connection can be created. Okay, then go through create peering connection, click on it, and after this you will be receiving message on the top, finance has been requested, right? And then you will be able to receive, oh sorry, accept request. Okay, you can see here pending acceptance by this. Okay, so you have to accept so that you can start pairing. After clicking on accept request, you can see status is with active, and uh, it, status also connection also has been established. Okay, uh, requester have requested the request, and acceptor have accepted the request. Now what else we have to review? We have to because as we have seen in concept that we must manually configure IPs to make communication between them. Also we have to review security groups. So okay, let's go and start. Okay, first I will go through marketing server, because a marketing server need to communicate with finance, and I will connect through subnet ID, where I will be moving to route table. Okay, after route table I will select another tab, routes, and edit routes. Here you will be now, because I am connecting from marketing to finance, and you have seen that finance is destination of, and I have to add rule. Okay, my destination is finance server and peering name is this, because request has been approved and accepted, and then I will be saving these changes. Okay, so status is updated successfully, and definitely same I will do for finance. In finance routing table, I will providing IP of marketing server, IP as a destination. You can see here same configuration, and we need to select peering connection name as well. After this, click on save changes. Status is updated. Now, before going to configure and review security group policies, first we have to check either I can ping or not. You can see still I'm not able to ping. Then I have to review, is it inbound and outbound setting configured properly or not. So let's start and review. After selecting finance server, I will go security groups, inbound, because finance server is accepting, yeah, because marketing server is communicating with finance, so I have to check inbound of finance servers. So edit inbound. Okay, you can see you have to click on add rule. You have to provide custom ICMP IP version 4 protocol all. It's mean from any protocol, uh, marketing server can send request to finance server, and here is source. In routing table we have provided destination, and because it's inbound, and I have to mention what is source from where request will be coming. So it's a 10.10.0.0. Okay, so I have to save changes, and then you can see it start communicating. I can ping. Okay, so congratulations for this session, completion of this session, where we have also discussed its limitations, configuration, all of this. And today, as we have discussed, that today we will be uh, doing hands-on example where we can see how we can create VPC, virtual private clouds and instances within that VPC, and then we can how we can configure and see that how VPC peering connections works, right? And you know already that we have discussed its life cycle, sender and receiver. One VPC send request for peering to another VPC, and another VPC can reject or accept that one. Otherwise, it can be failed, expired, or deleted. Okay, so let's move to the use case, and let me start. Okay, so first of all, I will be creating virtual private clouds, right? As you know that by default, whenever we create EC2 instance, we already have a default virtual private cloud, as we discussed in previous session, which is by default assigned to any AWS account. And definitely with that AWS account, it's also depends on privileges and permissions of what type of account do you have. Right now I am having only EC2 free tier account, and there might be some possible limitations and issues we can face, but I will try to present my best level. Okay, so right now we are going to create first VPC, because definitely we already have default VPC and we can also use that one, but I want to show how we can create a new one. Okay, first of all we will be going here and create VPC, and here you have different options. Right now you can ask your AWS platform to provide all available facility, or you can also create a uh, with minimum configuration and resources, so that you can also assign some IPs and a number of configuration like security groups and other routings as well. Okay, so I'm going to select VPC and more, so that I can save time, and within specific time we can complete this example as soon as possible. So this is VPC, I'm naming it to A, and IP version 4 CIDR block, it is also assigning this one. We have already discussed, if we have two VPC with this CIDR block, then that between them we cannot create peering, because it's a limitation. These CIDR should not be overlapping. These IP range must be in different IPs must be in different ranges. Okay, so it is automatically assigned this one, and number of IPs you can see here total, and tenancy is also default. It is also asking of availability zone for this VPC. We can have 1, 2, or 3. Okay, so if we are going to create more than one instances or more than one VPC within a zone, same zone, then definitely we can have availability zone 1. So right now I'm going with default setting, and number of public subnets. If we need your VPC to be connected publicly from outside of AWS cloud platform, where we can use API gateway or any other connector to connect with your VPC, then definitely you can also use this one with public subnet. Otherwise you don't need to select this option. You can just select 0, because you are just going to communicate and pair VPC within your cloud platform. Okay, so number of private subnets, I'm also with providing default selection, and here you can see I'm also not changing. This is DNS option. You can assign default DNS host name, and you can enable its resolution by default, so that your VPC itself may have domain name system already automatically provided to this VPC. Otherwise, if you uncheck, you can also set or configure later on. So let me create this VPC. Okay, okay, great. You can see here I have created my VPC, which is VPC A. Okay, I also already have one VPC, dev VPC. In the meantime, I can show you how I can delete this VPC as well. So if you want to delete, you can just, okay, it's saying that there is any peering connection already available, and that's why you cannot delete this. So for that, first I will go to peering, VPC peering. I will delete that. Okay, in the meantime, let's do that as well. Yeah, here. Peering connections, and here you can see one already I have deleted, and this is available for acceptance pending, but I don't want to use this one. Delete everything related to this one. Okay, so now let me go back to my VPC, and now I believe I can delete this one, right? Okay, great. Apart from creation of VPC, we have also see how we can delete as well. So right now we have created one VPC with name of A, and now I'm going to create another VPC with name of B. Remember that we can also use our default VPC, but just I'm going to create for you to get more understanding. Okay, this VPS available CID are this, but remember that if we are going to create another one, that range should be in different IPs. Okay, so creating with this range will not allow us to pairing. So instead of creating new one and configuring lot of new settings and providing range of IPs, so let's we use already provided VPC. Okay, so now you have this one sender and this one receiver. First of all, you can see that there is no any uh, you can see here IP version 4 CIDR and another detail. Let me show you. We can see its routing table. Okay, here you can see routes already defined, this one. Okay, so let me go back. Because we have two VPC, and definitely within VPC we have to create some instances, and for that I have to go EC2 launch is EC2, EC2. Let's suppose I'm going to create for that my VPC A. Yes, I don't want any key pair. Here you can see, because you have created your VPC with name A. So if you are going to create new instance, now you have more than one VPC, and you can select any VPC in which you are going to create your EC2 instance. Okay, so automatically assign IP as disabled. You can also enable it, and this is your security configurations, and this is another your access configuration. With SSH you can connect with this instance from anywhere. Okay, so there is no more any configuration, and let me create it, launch this instance, view. You can see here I have created new instance A, which is in states pending, and let me create in the meanwhile EC2 instance B, and same configurations, instance type same, because it's I'm having accounts free tier, and so that's why I don't want to be charged. And now you can see definitely I'm going to create another EC2 instance, and I want this EC2 instance to be created with default uh, VPC. Okay, one thing which I forget in previous creation of EC2 instance, I forget actually Zoom subnet. So right now I have provided also subnet, and here is automatically provision of IP, and now I am going to launch it. Okay, so definitely I have to configure it, and I have to also provide subnet. But let's see without configuring, because there is no any I automatically IP assigned, and I have not assigned this EC2 instance to any region with subnet. Okay, so let's back to the point, and now we have two VPC with two instances. Okay, one instance in one VPC, and let me also review the configuration and I mean routing security configuration. Okay, so here you can see it's a private IP assigned to this B, and here is private IP, because for A I did not select any automatic uh, provision of IP address, so that's why it's blank. So because this instance will not be able to communicate publicly, but B will be able. So because we are just providing communication between A to B, uh, and we don't need we can go with both configuration at the moment. Okay, so I will first go and create peering. These peering already created and deleted, so that I can show you how we can create new peering, right? And here let's say A want to be pair with B, and here you must be select requester. Now your requester is A, then definitely you will be selecting A here, and its CIDR 10.0.0.0 and again here you will be selecting default VPC, and it's in different IP range. Okay, and now you can see here the value become A B, what we have provided above, and I will create peering. So A has sent peering to B, and here under action B need to accept this request. Okay, otherwise it will stay in pending state, and after some time, after a week, whatever is default time, it will get expired. Also you can see you can also reject it also. And now, because we are going to complete this example, we have created this peering. Okay, and now it is with status active. Okay, what is the next step? Next step is to take care of their routing, and we have learned in previous session that we need to provide configure routing. I mean the IP subnet of A must be source in group policy of B, and in target of B. Okay, and the same goes for B. The subnet of B will be source of group policy of A and target of routing configuration. So let me show you with example as well. Here you can see, and okay, let's suppose we have A, here let me write 10.10.10, sorry, 10.0.0.0 oblique what it was. Let me see, EC2. if let's suppose it's my A, and let me go into subnet and see what is its subnet. You can see, yeah, 10.0.16.0, 10.0.16.0 slash 20. Okay, let's suppose this one is A. Okay, and let's suppose this one is B, which is in different configuration. Let me show you. Here B, you will select B, and then definitely you will be go for subnet, and we can see what is its subnet. Yes, here is. Okay, so right now this is A and this is B, right? We have to provide this subnet in B. Okay, now you can see, sorry, I was not presenting my slide. So you can see that we have A and then we have B, right? We must provide subnet of A. Please ignore that one, right? Let me draw, and yes. We must provide subnet of A in routing as a target of B, and in security configuration as source, and same subnet of B we must provide as a target in routing and source in security configuration, right? Okay, let me do that for you, and let's see how it will go. Again, before that, I would again like to request you to please subscribe, like, and share in your circle. If you already have subscribed, then you can like and do comments for me so that I can improve in more and more. And then please don't forget to share in your circle. And now back to the use case, and let me show you how we can configure all of this. Okay, so first I will go to EC2 instance. Remember that first we are going to review the subnet of B, and we will configure subnet of B in A as a source and destination. Okay, I copied it, and I will go back to EC2 instance. Now we are going to provide detail of B inside A. First of all, we will look into security configuration, and I will, because as a inbound we have to add IP version 4. This is as a source. Okay, so from this, I mean A, B will be, oh sorry, from B, because this is a instance of VPC-A. So I'm providing B subnet as a source, because A will be communicating with B. So B will be source of for A. Okay, and you will just save these changes, and now you will go again back to instances, and here you will go in detail, and now we have to configure routing. Okay, route table, and here I have to provide route, add route. Here is target for A, it's a B subnet, so target is A. Okay, and you can also provide peering connection, because these have agreed and requested and accepted. Okay, great, this uh, done successfully, and now we will be back, and you can see I will search for, now I have to copy subnet of A, right? Because now I'm going to configure B, right? We can see here what is subnet of A, 172.3.1.0.0.20. Let me go into B, into security, and security group, and let me edit, add rule, IP version 4. Now it's 172.3.1.0.0. Is it 16? Sorry, is it 20? Wow, yeah, here is. Okay, so I have configured both. Sorry, it's still we have to configure routing, because as we don't have set target, right? We have updated source for B, which is A, and now we will be setting target as A for B. Okay, subnet, and now we will be selecting this, and here is route table, and this in routes. Great. uh, it would be sources 10.0.16, 10.0.16 dot 0.20, 0.20. Okay, peering connections, you can see A and B. Great. So these two are major configuration and settings we have to provide in A and B, and now A can communicate with B, and please do this practice your own, and do let me know if I can help you. In any case, if you are having any problem, then please don't forget to uh, ask me. I hope you enjoyed what is VPC peering and how we can communicate between them. And today it's a very good session, because every system, most of the time we need a database, and today we will be discussing relational database service. What Amazon provide us regarding relational database service. First, we will discuss its overview, availability and durability, how Amazon provide us availability in any shortage, any disturbance, and durability of data, admin burden, how Amazon provide a feasibility to reduce the burden of admin level, and also it provides scalability. Scalability mean whenever we need some more instance or more data, it will automatically be provided. Manage and cost, how we can manage automatically with the AWS, and how we can cover cost of RDS. Apart from all of this, we will look into this the security of RDS. So as we have discussed that this session is first session of RDS where we will be discussing uh, concepts only, okay, and in next section we will be discussing use case, and then we will go actual implementation. So let's start for this session. It's our database in practice, and let's see how it help us.
Amazon Relational Database Service. Amazon RDS Overview. Amazon RDS is a managed relational database service. Amazon RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity, while automating time-consuming administration tasks, such as hardware provisioning, database setup, patching, and backups. It frees you to focus on your applications. Amazon RDS provides you with 6 familiar database engines to choose from, including Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle Database, and SQL Server. You can use the AWS Database Migration Service to easily migrate or replicate your existing databases to Amazon RDS. Here are the key benefits. Easy to administer. Amazon RDS makes it easy to go from project conception to deployment. You can use the Amazon RDS Management Console, the AWS RDS command line interface, or simple API calls to access the capabilities of a production-ready relational database in minutes. You do not need to worry about infrastructure provisioning, installing, and maintaining database software. Highly scalable. You can vertically scale your database's compute, memory, and storage resources with only a few mouse clicks or an API call, often with no downtime. Many Amazon RDS engine types allow you to launch one or more read replicas to offload read traffic from your primary database instance. Available and durable. Amazon RDS runs on the same highly reliable infrastructure used by other Amazon Web Services. When you provision a multi-AZDB instance, Amazon RDS synchronously replicates the data to a standby instance in a different availability zone, AZ. Amazon RDS also has many other features that enhance reliability for critical production databases, including automated backups, database snapshots, and automatic host replacement. Fast. A DB instance is an isolated database environment running in the cloud. You can provision new RDS instances only in a few minutes. Amazon RDS supports the most demanding database applications with fast performance. You can choose between 2 SSD-backed storage options. In addition, Amazon Aurora provides performance on par with commercial databases at 1/10 the cost. Secure. Amazon RDS makes it easy to control network access to your database. It lets you isolate your database instances by running them in Amazon VPC and connect to your existing IT infrastructure through an industry-standard encrypted IPsec VPN. Many Amazon RDS engine types also offer encryption at rest and encryption in transit.
Okay guys, so we have discussed all these pillars in overview, like manageability, scalability, availability, security, and from admin point of view. So we will go in more detail uh, one by one, right? So move to the next slide.
Amazon Relational Database Service features. Availability and durability. Amazon RDS also offer features to enhance availability and durability for your production workloads. Turned on by default, the automated backup feature of Amazon RDS will back up your databases and transaction logs and saves them securely in Amazon S3 for a user-specified retention period. Your automatic backup retention period can be configured to up to 35 days. Automated backups enables point-in-time recovery for your database instance. It allows you to restore your database instance to any second, during your retention period, up to the last 5 minutes. Database snapshots are user-initiated backups of your instance, stored in Amazon S3, that are kept until you explicitly delete them. You can create a new instance from a database snapshots, whenever you desire. Although database snapshots serve operationally as full backups, you are billed only for incremental storage use. Amazon RDS will automatically replace the compute instance powering your deployment in the event of a hardware failure. Amazon RDS multi-AZ deployments provide enhanced availability and durability for database instances, making them a natural fit for production database workloads. When you provision a multi-AZ DB instance, Amazon RDS automatically creates a primary DB instance and synchronously replicates the data to a standby DB instance in a different availability zone, in the same or a different region. In case of an infrastructure failure, Amazon RDS performs an automatic failover to the standby. The standby DB instance is promoted to become the primary DB instance. Data is replicated back to a new standby DB instance to retain high availability. Since the endpoint for your DB instance remains the same after a failover, your application can resume database operations as soon as the failover is complete. No manual administrative intervention is needed.
Okay, great. We have learned how Amazon make available in case of any mishap, and how it is durable because it's internal automation and provision of resources within database like processor or storage. Each and everything is being by Amazon, right? Where there is no any burden of administration side, there is no any manual work. So this is the benefits of availability and durability. So let's move to the next slide, where how lower burden it's create for admin, right?
Amazon Relational Database Service features. Lower administrative burden and performance. First, let's start with the features that help you lower administrative burden. It is easy to use. When you create an Amazon RDS DB instance, you can choose the database engine, storage capacity, CPU, and memory of the instance. The DB instance class determines the computation and memory capacity available to a DB instance. Amazon RDS supports 3 types of DB instance classes. Standard, for general purpose instances. Memory optimized, for memory intensive applications. And burstable performance DB instance class for burstable instances, with the ability to burst to full CPU usage. Amazon RDS database instances are pre-configured with parameters and settings appropriate for the engine and class you have selected. You can launch a database instance and connect your application within minutes. In addition, DB parameter groups provide granular control and fine-tuning of your database. A DB parameter group acts as a container for engine configuration values that are applied to one or more DB instances. Automatic software patching. RDS will make sure that the relational database software powering your deployment stays up to date with the latest patches. You can exert optional control over when and if your database instance is patched. Best practice recommendation. Amazon RDS provides best practice guidance by analyzing configuration and usage metrics from your database instances. Recommendations cover areas such as database engine versions, storage, instance types, and networking. You can browse the available recommendations and perform a recommended action immediately. Schedule it for their next maintenance window, or dismiss it entirely. Performance. Amazon RDS provides 3 storage types, which differ in performance characteristics and price, which means that you can tailor your storage performance and cost to the needs of your database workload. Amazon RDS General Purpose Storage, also known as GP2, is an SSD-backed storage option that delivers a consistent baseline of 3 IOPS per provisioned gigabyte and provides the ability to burst up to 3,000 IOPS above the baseline. This storage type is suitable for a broad range of database workloads. Amazon RDS Provisioned IOPS Storage, also known as IO1, is an SSD-backed storage option that's designed to deliver fast, predictable, and consistent I/O performance. You specify an IOPS rate when creating a database instance, and Amazon RDS provisions that IOPS rate for the lifetime of the database instance. This storage type is optimized for I/O-intensive transactional OLTP database workloads. You can provision up to 40,000 IOPS per database instance. In addition, Amazon RDS also supports magnetic storage, also known as standard storage, for backward compatibility. We recommend that you use general-purpose SSD or provisioned IOPS for any new storage needs.
Okay, great. So from admin side, admin point of view, admin don't need to ever have to backup manually. Admin don't need to select criteria of scalability, and there is also provided log management system, and also there is a different type of storage, and it's automatically being managed and done uh, by Amazon RDS, right? So let's move to the next slide, where we will be discussing manageability and cost effectiveness. Sorry.
Amazon Relational Database Service Features. Manageability and cost effectiveness. Here are the Amazon RDS key features related to manageability. Monitoring and metrics. Amazon RDS provides Amazon Cloud Watch metrics for your database instances at no additional charge. You can use the RDS Management Console to view key operational metrics, including compute, memory, storage capacity utilization, I/O activity, and instance connections. Amazon RDS also provides enhanced monitoring, which provides access to over 50 metrics, including CPU, memory, file system, and disk I/O metrics, as well as Performance Insights. Performance Insights is an easy-to-use database performance tuning and monitoring tool that helps you quickly access the load on your database and detect performance problems. Event notifications. Amazon RDS can notify you using email or SMS text message of database events through Amazon SNS. You can use the AWS Management Console or the Amazon RDS APIs to subscribe to over 40 different database events associated with your database instances. Configuration governance. Amazon RDS integrates with AWS Config to support compliance and enhance security by recording and auditing changes to the configuration of your DB instance, including parameter groups, subnet groups, snapshots, security groups, and event subscriptions. Here are the key features related to cost effectiveness. Pay only for what you use. There is no upfront commitment with Amazon RDS. You simply pay a monthly charge for each database instance that you launch. When you're finished with a database instance, you can easily delete it. Reserved instances. Amazon RDS reserved instances give you the option to reserve a DB instance for a 1 or 3 year term, and in turn receive a significant discount compared to the on-demand instance pricing for the DB instance. Stop and start. Amazon RDS allows you to easily stop and start your database instances for up to 7 days at a time. This makes it easy and affordable to use databases for development and test purposes, where the database is not required to be running all of the time.
Okay, great. We have also seen that how Amazon AWS RDS provide us manageability, where we can manage our database with different options, and we also have cost effectiveness, how we can decrease our cost. It can be automatically release resources when if there is no any need for that, and a lot of more. So we also have a number of types regarding event notification. We can governance on configurations. We can monitor the metrics, and we can identify the uh, pain points of our database's performance. Okay, so let's move to the next slide, and which is scalability.
Amazon Relational Database Service Features. Scalability. Here are the key features for scalability. Push-button compute scaling. You can scale the compute and memory resources, vertically up or down, up to a maximum of 32 vCPUs and 244 GB of RAM. Compute scaling operations typically complete in a few minutes. Easy storage scaling. The Amazon Aurora engine will automatically grow the size of your database volume as your database storage needs grow, up to a maximum of 64 terabytes, or a maximum you define. The MySQL, MariaDB, Oracle, and PostgreSQL engines allow you to scale up to 64 terabytes of storage, and SQL Server supports up to 16 terabytes. Storage scaling is on the fly, with zero downtime. Amazon RDS read replicas provide enhanced performance and durability for RDS database (DB) instances. It helps to offload read-heavy database workloads. You can create one or more read replicas of a given primary DB instance within an availability zone, cross-AZ or cross-region. The read replica operates as a DB instance that allows only read-only connections, while master or primary DB instance allows both read and write connections to your application. Updates made to the primary DB instance are asynchronously copied to the read replica. Using read replicas, you can elastically scale out beyond the capacity constraints of a single DB. This increases the aggregate read throughput. Let's look at a common use case. You want to run a reporting application that performs some analytics on the RDS database. In order to reduce the read traffic in the primary database, you can create a read replica for the reporting application to read data directly from the read replica instead. Read replicas can also be promoted to standalone DB instances as a disaster recovery solution if the primary DB instance fails. As you can see, read replica helps scaling out read operations. What about write operations? Amazon Aurora Multi-Master Clusters feature provides the capability to scale out both your read and write operations. In a multi-master cluster, an Aurora cluster consists of a set of master database nodes and a shared storage volume across multiple availability zones for high availability and durability of user data. All DB instances can perform read and write operations. The multi-master cluster doesn't use the failover mechanism because it doesn't need to promote another DB instance to have read-write capability. It offers continuous availability. Any DB instances in this case can take over the work of the failed instance.
Okay, it's really great that because this is the feature we mostly demand, where we have lot of search criteria or readability, where we need number of reads maximum. Then this Amazon actually provide a mechanism where we can create replica for read only, right? And we can have our primary database for read and write. For this example, I can provide you in Facebook, if you have create your profile and the same time your friend or anyone else cannot, if try to search, there is no any guarantee to be available at the same time, because they have a replica where user can read, but for creation of uh, Facebook profile, it is all created in primary database. So in these situations, definitely we recommend cloud computation apart from these RDS services. So let's move to the next slide, which is almost last one. It's a security.
Amazon Relational Database Service features. Security. Here are the key features. Network isolation. AWS recommends that you run your database instances in a virtual private cloud, VPC, which allows you to isolate your database in your virtual network. VPC enables you to run a DB instance within a private subnet, making it secure from direct public routes on the internet. You can control network access to your DB instances in VPC using security groups at the instance level and network ACLs in the subnet level. VPC traffic are connected to your on-premises IT infrastructure using industry-standard encrypted IPsec VPNs and can be further inspected by your on-premises security infrastructure, including network firewalls and intrusion detection systems. Resource level permissions. Amazon RDS is integrated with AWS Identity and Access Management, AWS IAM. It provides you the ability to control the actions that your AWS IAM users and groups can take on specific Amazon RDS resources, from database instances through snapshots, parameter groups, and option groups. You can also tag your Amazon RDS resources and control the actions that your IAM users and groups can take on groups of resources that have the same tag and associated value. For example, you can configure your IAM rules to ensure developers are able to modify development database instances, but only database administrators can make changes to production database instances. Encryption at rest and in transit. Amazon RDS allows you to encrypt your databases using keys you manage through AWS Key Management Service, AWS KMS. The database uses a customer master key stored in AWS KMS to encrypt the data keys, which encrypt the data at rest in the database. Its automated backups, read replicas, and snapshots are also encrypted. Amazon RDS supports transparent data encryption, TDE, in SQL Server and Oracle. Transparent data encryption in Oracle is integrated with AWS Cloud HSM, which allows you to securely generate, store, and manage your cryptographic TDE master encryption keys in single-tenant hardware security module (HSM) appliances within the AWS cloud. With TDE, the database software encrypts data before storing it on disk. In addition, Amazon RDS secure data in transit. You can use Secure Socket Layer (SSL) or Transport Layer Security (TLS) from your application to encrypt a connection to a RDS DB instance.
Okay, great. In this session, we have learned
Amazon Relational
different
Database
things
Service features. Security. To encrypt a connection to a RDS DB.
like first one was isolation, where we can have RDS in isolated VPC, virtual private cloud, and second one was encryption. All data is encrypted while transferring from one point to another point, and also it's provide IAM, identity and access management, where admin can provide and set rules for different users, so that if you don't want someone to modify or create any data in the database or any record in the database, then you can only assign and set rule for that particular user, only read only. So these apart from it, because in early ages we do a lot of this manually and we have to use programs and third parties. So right now we are having actually all in one place, and that is AWS providing us. Okay guys, thanks for watching, and I believe you have enjoyed this session as well. We will be discussing RDS use case with some example where we will be creating replica of your primary database. So let's start. I will be writing here RDS, then select RDS, create instance. Okay, right now I can create easy create and with standard. So with standard I will be having many different options like automatic backup, maintenance, security, group security, and zone availability to be choose by AWS. So in easy create, definitely few features I have to go through. So I'm going to select engine of RDS Maria, and here is version where I'm going to select another version, and because I'm not going to work on production environment, so right now I can choose dev and test. Also I can go with free tier. Definitely whenever I will create this database, it will cost me. So because I'm just going to explain every step and purpose and reason behind that selection and of every options. So this video actually is covering all those selection and features provided by RDS. We have covered in previous session a lot, but definitely practically example and discussion help us more, so that's why we are going to create this session. It's a instance identifier we don't need to, we can change it as well. It's a username. We can also create because I'm going to self manage. Okay, if you want to manage by AWS secret manager, then definitely you don't need to provide password and also other things. But right now I'm going to manage it by myself, and I don't want to generate automatic password. And here is I am going to create password. It is saying that it's a week, so okay, sorry, let me change it. Okay, again here I will be selecting bus table classes. The bus table classes are the classes, these actually require less utilization of processing. And when you have any deployment, any system where occasionally you get any performance issue or heavy load, heavy traffic, then you go for this selection. Otherwise you don't need to do this, because these type of selection accumulate a credits, and utilize those credit whenever required. Otherwise it's a good option to save uh, amount of lot of amount. So I'm going to select general purpose storage. Here I will be decreasing storage. Might be I can select 10. Advanced setting, okay. Not allowing me at least 20. So I don't want to change anything here. Auto scaling, yes. Uh, what the purpose of this option is, whenever our database will reach 1000 GB, system which automatically create new instance for us for application to be available. So we don't need to manage it manually, or we don't need to take care of it. Okay. And yes, here is another option, uh, requirement to have another backup standby instance in availability zone. So instead of specifying myself that I want this standby instance in zone A, B, or C, let system to decide. Let's suppose your primary database get down or get failure, and it will automatically create as a standby instance and will make available instantly, right? And you don't need to worry about it. Your application will never get down. So it's another good feature provided by cloud platform AWS. So yes, I don't want to connect with EC2 right now, because this is not part of this use case. So I'm going to select don't connect. As you know, we already have default VPC allocated to our account, so I'm going to select that. And there would be subnet, and definitely I'm going to select default. And I don't want to set public access, because I in this session we are not going to create a database where we will be connecting this database with any other application outside of VPC, or from any other application deployed or working running another machine on the internet. So that's why we don't need to select this. Otherwise, selection of this option, AWS provide a public IP where we will be utilizing and providing to those who will be utilizing this database. So security group, you have already did some practices while creation of VPC and EC2 we have already covered, and you can also create new security group. Otherwise, you can also select any already created. As you have seen in last sessions, we have created like kind of these security groups, and right now I'm going to select default again. I don't need to set any proxy, and yes, port is, you can also change this port which is default 3306. Password authentication, yes, because I have created password, I don't need any more enhanced monitoring. And you can see, you can also provide your initial database name, okay, whatever you, let's suppose I provide max the service, right? Backup, if you need backup, you can also change frequency of your backup, and you can also set it as a default. And yes, encryption is, it is also main feature of this cloud computation. And enable auto upgradation, no, I don't need this. Even though you can select, there is no any impact on charges. So these are the selections and purpose of every options I have explained you. And after creating this database, it will hit me uh, 29 USD charges, okay. So once database get created, then from options you can go through and select create replica. Definitely you will be wondering why I'm not showing you, because I have provided you short video. In that video you can go through and see the last screenshot. There would be an option create replica database, and the system will automatically create replica database with same configuration, and that replica database you can utilize for further usage. Already covered session 14 with short tutorial where we are just going to present you steps taken to create some groups and user, and then assignment of those groups to particular users. Okay, so this is a detailed session where we are doing some practical example, and where you can watch that how we can create groups and assign some policies, and then we can create user, and then need to assign those groups to newly created user, so that user must be only do the activity uh, already assigned to, or group assigned to them, right? So previous session was it's a short session where we discuss elastic file system. We review how to create EC2 instances, create reviews security groups, and also created file system, and all those file system mount to the compute instances in your private cloud, virtual private cloud, okay. So today we are going to do in detail, because we already have short tutorial uh, how to create group, then assign some policies to that group, and then create user and assignment of group and users. So let's start to do some practical example. I'll log in my Maxi service account. Okay. Okay. So let's create. Let's search for IAM. Okay. Here you have IAM. You can see I have already created one users and one user group as well. So just to avoid confusion, Let me delete that user. And also I have created group, and let me delete that group as well. Okay, so I'm going to create new group. How we can create that? Let me show you. Let's suppose I'm going to create only read only access. Once I create this read only access group, whenever I will assign this group to any user, that user will only be able to read. That user cannot delete or edit or create anything else, right? So read only access group, right? And I'm going to also assign read only. Let's suppose I'm going to assign this policy, uh, Amazon EC2 read only access. Any user assigned to this group will only can read EC2 read only access. This user cannot create any resource on cloud, cannot delete, just can read. So let me create this. Okay, you have created this user, and now, sorry, group, and now we are going to create username. It's a user. Okay, I okay, here is private user access to this management console. Yes, it's optional. And here one thing more which uh, I want to create an IAM user. I don't want to specify user identity center, right? So because these are the operation which highly recommended when you have professional or official environment, right? So for having some practice, I'm going in different way. So it's a password. I'm going to create password because I have to log in once user is created to show you, right? And user must create no. You this option is recommended whenever you create new user with any password, AWS generated or any manual generated as I have created here. User first after first login, it will be redirected to another page where user need to change its password so that anyone originator creator of password don't know your user. Okay, this is for official and uh, secure purposes, but right now we are not going to do anything related to that. So that's why we can also show password. But okay, let me move forward. Okay, use permission boundaries. Don't, no, I don't want to do this. Okay, so here you can see add user to group. So which group you can also select from here, number of groups. But I have created my own group and want to assign this new group to new user, right? Just for testing. Next, you can also add this like job title, and it's let's suppose in guest user. Okay, guest, and just you can move on, create user. Okay, here is URL for this new user, uh, and you can download CSV file as well, and return to the user list. Continue. Okay, here is your user created. Now we need to check either we can download this with new user or not. So let me check. We will be hitting this URL. My user is read only access user, password is, yes, you can see new user is able to log in, and as we uncheck the option to change password at your first login, that's why it's allowing me to go through, and I can also see if there is any already created EC2, but I cannot launch instance, I cannot create new instance because I have don't any permissions. Okay, you can see here is an issue. If I'm going to, let's suppose, delete security group, okay, here you can see because I'm unauthorized, I can just uh, view, I can just view the EC2 instance, I cannot do anything else because the group assigned to me have some policies, rules and regulation. So this is already assigned and I cannot do anything else. Okay guys, so this was a really nice session where you have covered IAM with basic information. So please